Okay, so now we're going to solve a quartic. Okay, quartic means the highest exponent is 4, so we should expect 4 solutions. So we're going to start out with y equals x to the 4th minus 3x cubed minus 13x squared plus 51x minus 36. Okay, so again, using the rational root theorem, we know that my possible rational roots are made from the constant terms factors and the lead coefficient terms factors. So 36 has a lot of factors. It's a kind of a number that they call factor rich. So we need to write them all down. Now, luckily for us, the lead coefficient has it's 1, so all right. So now remember that the rational root theorem only gives us a list of possible factors. So we're actually going to have to go through one by one and see if something works. So the easiest ones, remember to try out, are 1 and -1. So we're going to start there. Remember that you are looking for x-intercepts. Which means you're looking for values of x that produce y equals 0. Okay, that's what you're looking for. So what we're going to do is we're going to plug in a 1 and see if that gives us a 0. Hopefully it does. So wherever you see an x, you're going to put a 1. Okay. All right. So if I work that out, I get 1 minus 3 minus 13 plus 51 minus 36. So that would be, let's see, negative 18. Oh, wait. It would help if you wrote the problem down right, wouldn't it? Okay, so we've got negative 15 and then positive 15, and that gives us a 0. Now remember what this means is it means that x equals 1 is a solution. It also means that x minus 1 is a factor. Okay, and remember that factors will divide things evenly. Okay, so what we're going to do is we're going to use x minus 1 to divide our quartic. Okay, we're going to use long division again. So our x minus 1 goes on the outside. So x to the 4th minus 3x cubed minus 13x squared plus 51x minus 36. Okay, when we use long division, remember we're always going to lead off the x. Okay, the very first term that we see in our divisor. So what we need to do is think of how do we get an x to be an x to the 4th. So we're going to multiply by x to the 3rd. Then you're going to distribute. Now, when you long divide, remember this from, I think elementary school, you subtract, so you're going to change the sign. So that's going to be negative 2x cubed. Bring down the next number, like that. All right, now what do we need to do to multiply an x and get a negative 2x to the third? A negative 2x squared. Again, distribute. Again, we're going to subtract, so that means we change our signs. So those zero out, and we get negative 15x. Bring down the 51. Okay. We're going to multiply again. All right, let's see here. Negative 15x, so we need a 15. X squared. So 15x, sorry. Okay, so let's see here. Negative 15x squared. And then negative 15 times a negative 1. That would give me a positive 15x. So we're going to change our signs again. It's very easy to kind of get lost in this. So be very careful. Okay, now we notice we need a 36x. So to get that, we need to multiply by a positive 36. Again, distribute. Change your signs. And you get a 0 as a remainder. So now what that means is we need to find factors of x cubed minus 2x squared minus 15x plus 36. Okay, so we reduced our polynomial by a degree. So now we need to find factors of x cubed minus 2x squared minus 15x plus 36. Okay, so luckily we can go back to our original list of rational roots that we created in the very beginning, and we can try those guys out. Now, just because we used one, it doesn't mean we can't use it again. We actually can, but just looking at the coefficients, I can tell you it's not going to work. So we need to go for other numbers. So I would try 2. So if I try 2, I get 8 minus 8. Looks promising, but I actually get a 4. And since 4 doesn't equal 0, x equals 2 doesn't work. Okay, so now, the next number on my list is x equals 3. So let's try x equals 3. Usually what I do is I run through the positive first, and then I run through the negatives. Just, I don't know, it's a habit. But you can do positive, negative if you want. Okay, so that would give me 27 minus 18 minus 45 plus 36. So let's see, 27 plus 36, that would be 63. And negative 18 and negative 45, that's a negative 63. Hey, look at that. X equals 3 gives me a 0. So that means x equals 3 does work. Okay, so what that tells me is that x equals 3 is a x-intercept. It is a solution. And my cubic now is divisible by x minus 3. So now I can divide again. But this time I'm going to divide the cubic. I'm trying to get my polynomial to the point where it's a quadratic and I can deal with it. Okay. All right, so again, we're going to do long division. So let's see, lead off the x. I need an x cubed, so that would be an x squared. Bring it down. Okay, since you're long dividing, change the signs. Next term down. Okay, now I need an x to be an x squared. So I'm going to multiply by an x. Change the signs. Bring down your next term. Okay, I need my x to be a negative 12. And notice, once I change my signs, I get my remainder of 0. So that means, okay, that, here's what I have so far. I have, this is where we're at. We started with x to the 4th minus 3x to the 3rd minus 13x squared plus 51x minus 36. Okay. Then we found that x equals 1 worked, which told me that x minus 1 was a factor. So we know that x to the 3rd minus 2x squared minus 15x plus 36 times x minus 1. Then we broke that down. Okay, and we got x to the 2nd plus x minus 12 is equal to x minus 3 times x minus 1. Now the cool thing is now this is something that I can deal with. I can factor it. I can use quadratic formula. I can do what I need to do. So this is pretty easy factoring. So I need to come up with two numbers that multiply to negative 12, but add to give me 1. So that would be that. Okay. So now I have my 4 factors. Okay. Notice I only have 3 numerical answers, but one of them appears twice. Okay. This is what they call multiplicity. Okay, is how many times a number appears as a solution. And x equals 3 actually appears twice. So we count it twice. Okay, it's called multiplicity. And it actually has a really interesting effect on the graph. Okay, so I'm going to go ahead and show you a picture of this graph. Okay, now check this out. Okay, here is my negative 4. See how that crosses the x-axis? Okay, it crosses it. Okay, 3, if I look at 3, notice that over here it looks like it bounces off the x-axis, like it approaches it, goes down towards it, and bounces back up. Okay, so we bounce off the x-axis. We still touch the x-axis, so we're still an x-intercept, but we bounce off of it like a trampoline. And then if I look at 1, I again cross the x-axis. Okay, so notice that the negative 4 has a multiplicity of 1. The x equals 3 has a multiplicity of 2 because it appears twice. and x equals 1 has a multiplicity of 1. Okay, so based on the multiplicity, if it's odd, like 1, you will have a x-intercept that will cross the x-axis. So it'll go from positive to negative or negative to positive. If you have a multiplicity that is even, like 2, then your graph will bounce off the x-axis. Okay, so it's kind of interesting that how many times the solution appears actually affects how your graph looks. Okay, I hope this helped. I know this is a really, really long process. That's why I encourage you to use a graphing calculator if you can. Solving polynomials can be done by hand. And I think it's kind of fun, but also after all of that work, I would highly recommend that you do verify it with a graph. Okay? Again, I hope this was helpful.